All right, ladies and gentlemen, we finished on Tuesday with all of the different extinctions. Today we're going to talk about the threats to biodiversity, what leaves you vulnerable to that idea of extinction. First one that we need to kind of revisit, we talked a little bit about it on Tuesday, is the number of species that are out there. This slide says about 7 million. The slide that we had last week said about 8.7 million. Do we really know how many are out there? No, we have no clue. It's the best guess. There are a ton of species we haven't discovered yet. We do know most of what has been named, that has been discovered, is terrestrial. Why not ocean animals? Hard for us to travel through the ocean. 70% of the planet is ocean. Oceans are really deep, and they are not hospitable to humans. So when we talk about what's left to discover, there are some terrestrial things left to discover. There are a ton of things in the ocean left to discover. We had a huge tsunami about 15 years ago in Indonesia, and there were deep sea species of fish washing ashore that looked like little monsters that no scientist had ever seen before. We know that 2/3 of our species are found in the tropics. This is why 10 of our 30 hotspots are in the tropics. There is high species diversity there. We know that most of what we have discovered and named are mammals, followed closely by insects. And the reason why insects follow closely as far as name is because there's a lot of weird insect people out there, right? There are people who like to collect beetles and pin them and keep a collection, I know, it's gross, of beetles. And beetles, therefore, are the #1 named group of species because of these weird beetle people. Darwin was a weird bug person, and so he went around and collected all of these bugs. We know that things that maintain diversity are the complexity of the ecosystem. Are there a bunch of niches out there for these animals to live in? We know that a climax community has a bunch of niches, is a complex environment. We know that we need enough water and food and territory for our species. So is there enough of all of those things that could limit the population? And last but not least, this idea of inertia. If a population is healthy, if an ecosystem is healthy, it tends to stay healthy. Once we start getting our human hands in that ecosystem and we start messing with it, the inertia tends to disarray. Think about this on your own, right? I was grumpy yesterday to begin with, and then I sat in the car at the Great Park for like 4 hours, which made me even grumpier. And then I got home and one of my kids just pushed me right off the ledge. It's that inertia. I was already trending towards grumpy, and then there was like a nuclear bomb in my house when I threatened to take away cars for the rest of their existence. It's that inertia. Same thing's happening in the environment. If we start disturbing the environment, that environment becomes more vulnerable to disturbance. Okay, so what leads to our loss of diversity? The first thing you need to realize, because it's often a test question, is that we can lose diversity due to natural occurring events. Man does not have to be the catalyst. Naturally occurring events like flooding and wildfires and hurricanes, out of the control of humans, impacts these organisms horribly. So in 2007, the Yangtze River in China flooded. Well, if you're a terrestrial animal that lives on the banks of the Yangtze River, you're going to drown. Humans had no control over that. Same thing when Hurricane Katrina came in. We know that there's 4 to 5 million acres of land burned in the U.S. per year. A lot of those fires are caused by lightning. If you look back at the journals of the original discoverers of California, when they made around the tip of South America and came up to California, everywhere they tried to come into port to make land in California was on fire because it is a natural part of our ecosystem. That being said, a lot of our current extinction, the Holocene extinction, is caused by man. And so we have natural disasters, environmental disasters. Give me some examples of environmental disasters that lead to a loss of biodiversity. The oil spills. What are our two big oil spills? Deepwater Horizon in the Gulf of Mexico and Exxon Valdez in Alaska. We know that we are encroaching on the habitat of species. We are getting rid of niches to build our homes and our roads and humans. So when we think about this, only 10% of the forests remain in the Mediterranean. By the way, is that a new thing that we've deforested the Mediterranean? It goes all the way back to the Greeks and the Romans. Habitat fragmentation in Southern California, we feel like we're doing a great job. So yeah, we build our houses and we encroach on the territory, but you know what? We're gonna leave natural space. We're gonna leave preserves. We're gonna make our regional parks like Irvine Regional Park and O'Neill. But those areas are fragmented. They're cut off from each other. The animals in Irvine Regional Park have a hard time mating with the animals in O'Neill Regional Park because there's roads in the way. And so, yeah, we are setting aside land and we're doing what we think is our best, but those fragmented kind of preserves are not the best for biodiversity. Pollution is a huge factor that leads to biodiversity. We just discovered a rare form of West Nile in Orange County. The news report just came out this morning. Well, West Nile is carried by mosquitoes, which means I guarantee in the next 2 weeks, we're going to start to see widespread pesticide spraying in Orange County. The way they do it around here is they have big trucks of pesticides that drive up and down the streets, and they actually will spray down the pesticides in the rain gutters. So anywhere where there might be standing water to get rid of the mosquitoes. Do those pesticides only kill mosquitoes? No. We have emissions from our factories creating acid rain and smog. It has gotten better since 1990 in the Clean Air Act, but it is still an issue. We have eutrophication from fertilizers. We have climate change due to increased carbon dioxide and methane in the atmosphere. And then we have our plastic pollution. And it's not just sea turtles getting straws up their nose that we have to worry about. As plastic sits in the sun, in the ocean, all of the chemicals from the plastic start leaching out. Some of those chemicals are what we call endocrine disruptors, so they disrupt the hormones of the animal. Eutrophication is one of those themes that you're going to hear over and over and over again. So just a quick review. It is a positive feedback mechanism. You have an influx of nutrients into a body of water from agriculture or from your lawns. That then provides all of the nutrients that algae need to grow in huge numbers. The algae then use all of those nutrients and die off, which then leads to all of the bacteria blooming to eat the algae. The bacteria then suck all of the oxygen out of the water, killing all other life. When we talk about our bodies of water then, we have the eutrophic lake. A eutrophic lake has undergone eutrophication. Give me an example of a local lake that has been eutrophic. RSM Lake. They haven't had fish in that lake for like 3 years. It's been a golden algae bloom due to all of the fertilizer that flows into that lake from the surrounding areas. They think they fixed it. There's actually fish in there now. We'll see. But it's been a eutrophic lake. That lake is hypoxic. Hypoxic is a new term. Hypoxic means no oxygen. The opposite of a eutrophic lake is an oligotrophic lake. An oligotrophic lake doesn't have any nutrients in it, or very little, And because of that, it doesn't have any algae growth, and therefore no primary producers. No primary producers, no food webs. What you want is this mesotrophic lake. Meso meaning middle. So this is like the middle ground. It's got just enough nutrients to get good algae growth and therefore good food webs, but not enough nutrients to cause a algal bloom. You've seen this before and you'll see it again, but this is your oxygen sag, where you have an influx of pollutants. So before that influx, you have a very healthy river, and then the pollutants come in and you see an algal bloom, which then dies off and causes a dead zone. This is hypoxic right here. And then as you get further from that discharge, that nutrients coming in, you go back to a healthy river. Other things that lead to a loss of biodiversity: overexploitation. If it tastes good, humans are going to hunt it almost to extinction. As our technology has gotten better, we have gotten better at killing things. So before World War II, if I made my job fishing, I would go out and I'd throw my nets out or I'd throw my line out, and I would hope that I am somewhere that there is fish. After World War II, we got sonar. And I can now cruise around on my boat using the sonar and actually find the school of fish and put my nets right on them, which means I am more efficient in catching the fish, and I can catch a lot more in a short amount of time. We have introduced a ton of alien species, also known as invasive species. That's what your poster is due on tomorrow. A couple of ways that we get invasive species. The first one is accidental release. We see accidental release with rats. Great generalists, survive anywhere. The way they were accidentally released is the boat's moored up somewhere. The rats run up the lines of the boat, get on the boat because there's a food source, and then the boat sails off with all of these rats. The next place they dock, some of the rats run off, and now they've been released into an area where there may not have been rats to begin with. Rats are now found almost everywhere. The idea of biological control is an interesting one. The golden apple snail was released into the rice paddies in Asia because there was a snail that carried disease, and the golden apple snail doesn't. And so they released the golden apple snail into the rice paddies because it could outcompete the snail that carried disease. It was kind of an idea, right? You could follow their line of thinking. Here's the problem. It outcompeted the snail that carried disease. Guess what the golden apple snail eats? Rice. So it was eating all of the plants that they were using as a crop. That was kind of a failed attempt. Most of our biological control, by the way, doesn't work out because we don't think 15 steps forward. We go, okay, I can release ferrets because ferrets eat snakes, and the snakes are a problem. Except for the ferrets very quickly realize that the flightless birds and their eggs are easier prey than the snakes. And so now you have two things killing off your native bird population. And we also released some things as food sources by accident. Rabbits were brought to Australia as a food source and got loose. And not now, but if you're bored at home, you can Google swarms of rabbits in Australia. And they literally swarm across the plains. It's kind of gnarly. In California, miners brought with them bullfrogs because they liked frog legs. The problem with that is bullfrogs are immune to this fungus called the Kittredge fungus. Our native frogs aren't, and it's a fungus that basically hardens the skin of the frogs. Well, if it hardens the skin of the frogs, then the frogs can't breathe, and so it killed off a lot of our native species. My favorite example, though, is snakes on the island of Guam. Guam is a military base, and snakes on a plane. The snakes came in from Texas and landed on Guam. They also came in on the boats.
The United States was reestablishing its Pacific Navy base on Guam. The native Chamorro people were happy to have them back after being occupied by the Japanese for the last 3 years.
The liberated Chamorros were unaware that a miracle had happened around them. A miracle that manicured their jungles into acres of black-topped airfields, moved mountains of materials, equipment, and supplies.
But the Americans had brought something they hadn't intended.
The brown tree snakes were in with the supplies, and when they just simply loaded the supplies up, carted them back to Guam, to the military base there.
These snakes hitched a ride.
At least one female.
Right, and there you go. The snakes loved Guam. No predators, lots of birds that didn't know anything about snakes, lots of eggs. The military began to notice a lot of power outages.
And you have the radar and all the other electronics associated with military activity. You want to keep your power up.
You do. Yeah.
As the population of the snakes got up, they were getting fried as they were short in the line.
Today, some areas in Guam have as many as 13,000 brown tree snakes per square mile. And the native birds? Out of 18 species in 1950, 7 are extinct. 2 exist only in captive breeding programs, like the Smithsonian's Conservation Resource Center in Front Royal, Virginia. Maybe someday they can go home. They may be the villains in this story, but the brown tree snake is only doing what comes natural: surviving. Their partner in crime, so to speak, was the U.S. Navy, who introduced them to Guam in the first place.
Okay, so to put this in perspective, our campus is about 1 square mile. The estimates for the brown tree snake in Guam is 13,000 snakes per square mile, which means on our campus there would be 13,000 brown tree snakes. Generalists will eat anything, lots of food source. They have done a lot of good in reproducing and a lot of bad in causing extinction. Now, the U.S. military caused the problem. The U.S. military is trying to solve the problem with military engineering. They know that the chemicals in aspirin will kill the snakes. So they've been killing mice and injecting them with aspirin so that when the snake eats the mouse, the snake dies. But where do these snakes live? In the trees. So you have to get the mice in the trees. U.S. military base. So they first airdropped mice that had been drugged with Tylenol. But all of the mice just dropped right out of the trees, so that didn't work. U.S. military engineering. They then decided to do it again, but this time they put parachutes and streamers on the dead mice and airdropped them. So now you are living on an island with 13,000 snakes per square mile, and they are airdropping dead mice with parachutes on you as well. Vacation spot, anyone? The other factor that leads to loss of biodiversity here is the spread of disease. A lot of diseases are species specific, which means a disease that a lion has, only a lion can have, and it's not going to transmit. But we do know that there are diseases that go from animal to animal. So my puppy, my favorite child, is a Rhodesian Ridgeback. These were dogs that were designed in Africa to keep the lions away from the gold mines and off the farmer's land. And they don't fight lions, they bay lions, which means they go up, they run up, bark, and run away. And then they run up, bark, and run away. This is my dog's favorite game with our older dog. And our older dog just has to stand in one place and bark, and he like does laps around the house. As they would run up and bark at the lion, they would spread distemper. And this is a disease that the lions would catch from these dogs. It's a disease that the lions didn't actually ever have, and so no lion was immune to it. And we started to see these lions dying of a disease that dogs recover from because we've introduced this other species into the territory. Our modern agricultural practices actually lead to a loss in biodiversity. We have gone to monoculture. we really like wheat thins, and so we now, as a culture, will plant entire states of wheat or entire states of corn. That means that there's less niches, less habitat, less animals are going to live there because now there's only one thing to hide in, which is a cornfield. And it's fun for a little bit, but then it dies off. We've also genetically engineered a lot of our crops, and we've picked the best traits that we want, and now all of the wheat looks the same and acts the same, so there's less genetic diversity. And we use our pesticides to make sure that that one crop is going to be happy and healthy, and we're going to kill off anything that might want to eat my crop. All of that leads to a loss of biodiversity. We are doing something to try and preserve biodiversity though, and that's our seed banks. So we know that we've manipulated a lot of our crops, both through selective breeding and now through genetic modification. We are going to keep heritage seeds. So what was a wheat plant before we started messing with it? What was a strawberry plant before we started messing with it? We're going to keep the seeds of those plants in our seed banks. We have seed banks all around the world. We have local seed banks that are going to have all of our chaparral plants. So if there's a wildfire, we can go back in with native seeds and replant that area. And in fact, that's one of the stewardship jobs that you can do through Irvine Ranch. You can go and collect seeds or sort through seeds. We also have the Millennial Seed Bank in Norway. This is going to store seeds from all over the world. The idea is that if we have a nuclear winter, if we finally lose it as a world and start bombing each other with nuclear bombs and wiping out most of life, we can go back to this Millennial Seed Bank and start again.
Just look at the landscape around us and how remote this is. And then jutting out of the side of this Arctic mountain is the Svalbard Global Seed Vault. And we have all been very excited to actually get inside and see for ourselves how what's being done here plays a very vital role when it comes to trying to mitigate against the consequences of climate change. So this is it.
This is it. This is the vault. This is what is built for humanity to survive. This is the Svalbard Global Seed Vault. It's here since 2008, built by the government of Norway, and it's one of the most amazing things you're going to see in your life. Yeah, they look funny, but they protect you against ice falling down in the vault.
It's that cold.
It's that cold. So that's about 150 meters down into the mountain. This is becoming the permafrost here in granite. They built this like they built the tunnels in the Alps with a big machine, a big excavator. Took about 2 years to build, and it's built to last for a very long time. This is meant to be your way out if the power fails, if there is no lights, so you find your way out of the vault. So the seed deposit works like with any bank and a safe deposit storage in the basement of the bank. You bring your own seeds, you as a depositing institution, you own them and you keep them, and only you can determine what happens with them. This is the main door to the active vault, one of the 3 vaults that we have. It's all frozen up because inside it's minus 18 Celsius year round. And this is typically the place everyone wants to have a picture taken. This is world agriculture behind that door. Everything you're going to need for the world to survive in terms of agriculture is safely kept here for the future. We have 860,000 types of crops. Each probe has 100 to 1,000 horns. So if you look at the number of individual grains in here, it could be close to 1 billion.
My nose is gonna fall off already.
You need to keep warm here with everything that you can. And when you go inside, it gets colder because of the draft of the AC. You could go back to Svalbard and recreate agriculture in the world, which I find an amazing concept.
In the event of a cataclysmic occurrence, this would stay and preserve these seeds for how long?
We have minus 18 Celsius in here. It would go up to minus 8, minus 7 after a few years. But then even at that temperature, most of the seeds can stay for many, many years, 10, 20, 30 years time. So you have a lot of time to think about what to do, even if power fails here and doesn't get restored. It's a safe place.
It is truly remarkable and such a unique experience. The general population doesn't have access to
So about 2 years ago, there was controversy with that seed bank. Syria wanted to withdraw their seeds. They've been in the midst of a civil war, and a lot of their crops have been destroyed, and they wanted to repopulate their crops with the seeds from the seed bank. Why was there a controversy with that? Is the war over? No, Syria is still in major conflict. And 2 years ago, they wanted to pull seeds. Well, the fear is that if they were given their seeds, that they would replant them, and then that land would be destroyed again, and now there are no backups. It spurred a huge ethical debate. But at the end of the day, just like they said in the video, those seeds belong to Syria, and Syria had the right to take them out, and they did. So far, so good, but we don't really know everything that's going on in that country. There are a couple of case studies that you need to know. The first one here is the tropical rainforest. We know that 50% of all named species are in the tropical rainforest. It is an area of very high biodiversity, which is why we try and protect it by making it those hot spots. We know that since 1950, we've already lost 8%. That number is probably higher if I were to research it today because of what's going on in Brazil's government. We have gotten rid of that land because it's very valuable for its timber. So we're cutting down the trees to have mahogany and teak in our houses. We know that there's oil and there's gold and there's diamonds underneath the land. In order to get to it, we got to cut down rainforest. We've been making palm oil plantations, monoculture, in where there used to be rainforest. We know that the rainforest tends towards disorder. Once we start disturbing the rainforest, it doesn't bounce back. It doesn't recover because there's not a really thick soil layer. And the nutrients that are there, if you do slash and burn agriculture, you put all of these nutrients in the soil by burning those trees, but it doesn't last there long because the soil level is so low, and any rains you have start washing those nutrients away, which means in a few years you need to move your farm and slash and burn a new area. So our rainforests are very vulnerable. Another vulnerable area, and what we have in the United States, are mangroves and wetlands. A wetland is defined as anywhere where fresh water and salt water interact, where they meet. And we know that these are areas of breeding. So in our wetlands, we have a lot of fish species that will breed. We know that we've got these mangrove forests in the south in the United States, and those provide habitat for a lot of animals. Think about everything that can live in and amongst and hide in those root systems. But not only that, they provide ecosystem services. The ecosystem provides something for the humans. The biggest thing that our mangrove forests are going to do in the south is as the hurricanes come in and the storm surge and the waves, they're going to lessen the force of those waves. They're going to absorb a lot of that. So if we have really big estuaries, the storm surge comes into that estuary, it doesn't impact the land that humans are living on. It's going to purify and filtrate the water. The mangroves are really great at absorbing excess nutrients that runs off due to agriculture. And if they're absorbing those nutrients and using it to grow bigger trees, then the algae is not going to bloom and we're not going to have eutrophication. We are paving over a lot of our estuaries. And if we pave over it, we lose that ecosystem service. We're doing dams that are preventing our fresh water from getting there. And a lot of our animals need that brackish, that mixed water to breed in. And there's eutrophication. All of this loss of biodiversity can lead to the extinction of different species. So the risk factors for extinction. First one is a very narrow geographical range. This species lives in only one place in the entire world. And if that habitat gets destroyed, that species goes extinct. Our little golden lion tamarin lives in Madagascar. That's the only place he lives. His habitat goes away, so does he. If there is a very small population size, we don't then have the numbers for reproduction. We don't have the genetics to ensure that when they do reproduce, that they'll be healthy. We consider these species the living dead. So the northern white rhino, there are 2 northern white rhinos left in the world. They are both old females, past reproductive age. The last male died 2 years ago, I think. What we do have, though, in San Diego, they maintain something called the Frozen Zoo. So they maintain embryos and cells and sperm and eggs from all of the species that have ever been at the zoo, or all the species that the researchers who work at the zoo have ever come in contact with. And it's cryogenically frozen, just like if you were to undergo in vitro fertilization and you have embryos and you get pregnant with, 1 baby and you've got 5 other embryos that then stay frozen until you decide what you want to do with them. Same thing is going on for our animals. And so we have these embryos of northern white rhinos. And right now the zoo is trying to come up with a way to impregnate southern white rhinos with a northern white rhino baby.
Doppler on, color Doppler. We're here today to do an ultrasound on Victoria Rhino. She was inseminated 53 days ago with frozen semen, and we discovered that she was pregnant at day 18 after ovulation, after insemination, and she's now at 53 days. Extremely blood flowing towards us. Developing artificial insemination techniques and embryo transfer techniques with these 6 females, so that they will be proven females, that we will know that they have proven themselves capable of carrying a fetus to term before we would risk putting a precious northern white rhino embryo into one of those southern white females as a surrogate. Here into the date, which is just so long. And every one of these is
So that's all well and good, but what's the problem with that?
it's going to be mixed.
It's not going to be mixed. It's an actual embryo from a northern white rhino, and it's just being carried by a southern white rhino because they're close enough that their gestation is the same. The milk is probably going to be the same. How many of those can we produce? Right? We're in limited number of the number of embryos that we have. And let's say even if we get a male and a female born, they're brother and sister. And it's not good practice to mate brother and sister together. Just like it's not good for humans, it's not good for animals. And so, yeah, we could get northern white rhino again, but it's still an end line, right? It's still not something that's going to repopulate the world with northern white rhinos. We could get a couple and have them in the zoo and it'd be cool, but that's where that ends. If the animal has a low population density and a huge range, so there's not a lot of them, but they need a big territory to find the food that they need. They are usually solitary organisms and only come together to breed. If they need a big territory to do that, we tend to fragment that territory. In China, we talk about our pandas. In California, we talk about our mountain lions. They are solitary organisms with huge territories, and they are now living in these fragmented little areas. And it's hard for a mountain lion in O'Neill to get to a mountain lion in Irvine Regional Park to have babies with. And so that they are therefore then at risk for extinction. if there are a very few number of populations. And so you've got a population over here that is isolated from a small population, 50 miles away. You're not going to have gene flow between those two populations. Lemurs are an example of this. And then last but not least on this list here are animals with really high body type. So our top predators that need a lot of food and therefore a big range are at risk of extinction. Our gray wolves were extinct in Yellowstone. We brought them back. They're thriving, but they're extinct in other areas of the world because of this. If they have low reproductive potential, that means that they only have, 3 or 4 offspring in their entire life, and it takes them 20 years to get to sexual maturity to even have a kid. There's a lot that can go wrong along the way. And so you have some individuals that never reproduce, and the ones that do are not reproducing at a sustainable level. Seasonal migrants are at high risk. They have long routes that they travel, and there's a lot of pitfalls due to humans along those routes. They need good habitats in both of their environments. In California, we have the swallows that are supposed to come back to San Juan every year. They're not coming back in high numbers because they don't have good habitat. They need mud to make their nests, and they need to be in areas that aren't going to be disturbed, and neither exist in San Juan in high numbers anymore because we've built all these homes. We are trying to build artificial nesting boxes for them to encourage them to come back, to give them that habitat, but it's tough going. If you're a plant that can only be dispersed or spread by one type of animal, and that animal goes extinct, the plant goes extinct. If you are edible to humans, if you taste good, you're at risk of extinction. That's a sad statement, but it's true. And if you're a specialist. Last but not least, if you live on an island, you tend to be a specialist. You tend to be dependent on that island, and if something changes on that island, you don't exist anywhere else, and therefore you go extinct. Dodo bird is a species that went extinct in the last 100 years. Brings us to this, the idea of a minimum viable number. Now, I talked about the fact that we could bring back a northern white rhino through this insemination, but we're only going to get a handful of them. That's way below minimum viable number. Never going to be enough to see that species really come back. We think for our large mammals, predatory animals, the minimum viable number is 500, which means to maintain genetic diversity and to maintain your population size, you need 500 individuals to exist. Sumatran tigers, right now there's only 400. Most of those are existing in the zoos. And San Diego Zoo is doing a good job at captive breeding to get that number higher, but we're sitting at about 400. Blue whales have rebounded since whaling ended for the most part and are at 700. So they're above minimum viable, but not by much. The IUCN is the International Union for the Conservation of Nature and Resources. This is an international governing board that is going to look at this idea of minimum viable number, of population sizes, of threats and loss of biodiversity, and they are going to try and come up with solutions to prevent extinction. A lot of the solution is education. So educating that maybe bushmeat, maybe eating great apes isn't your best food source, that we can come up with some other food source for you. They are also going to put restrictions on the trade of animals that are considered vulnerable or endangered. Every year they update the red list. Your red list is a list of animals that are endangered or critically endangered. This is then going to allow governing bodies to make laws and legislation to protect those species. When you look at the red list, animals are classified as extinct, which means that there is no reasonable idea of this animal existing anywhere on the planet. Have animals been declared extinct and then found? Yeah, the sturgeon, this ugly fish, was one of them, where we had declared it extinct and then found it in the Baltic Sea in like really high numbers. That's where you get caviar from. So animals have been declared extinct and then found. It's just rare. We know that there are animals that are extinct in the wild, which means they only exist in zoos. A lot of those animals, places like the San Diego Zoo, are trying to do captive breeding, are trying to increase the numbers. A lot of those animals, even if we were to increase their numbers, their habitat in the wild is gone. So they went extinct because of habitat encroachment, and even if we get their numbers back up, there's nowhere to release them to. Critically endangered means that in your lifetime, they will probably go extinct. They're already on that path, and again, inertia, once you start down that path, it's hard to stop it. Endangered and vulnerable, those are the ones that we can throw money at, that we can throw education at, that we can prevent the extinction of. Least concerned means that they're everywhere. Rats. We are least concerned about rats. They're not going to go extinct ever. Data deficient and not evaluated means that scientists haven't done enough research. We don't know where the population numbers are or what they are because we just haven't studied them yet. And that is where I'm going to end today. Go ahead and put your computers on lab stage 1 and 9 and then come back to your seat so I can talk to you.